This video is going to talk about the power of a velocity versus time graph. So by this time, you will have been introduced to three different graphs: displacement versus time, velocity versus time, and acceleration versus time. And probably the most useful graph for us is a velocity versus time graph, because from it, using the two calculations of slope and area under a curve, I can calculate the acceleration and the displacement, and I can get a sense as to whether it's a positive or a negative value as well. So this is a velocity versus time graph, and I have it in four different segments: a dark blue, a green, and a pink, and a purple. So just to remind us, in the first quadrant in a velocity versus time graph, something is moving forward or to the right. It's moving in the positive direction. And anything where I have values in the fourth quadrant of a velocity versus time graph, my object is moving backwards, or it's moving to the left in the negative direction. So for my four parts of my journey, only one part of my journey is my object moving in the forward direction. The other three parts, the object is moving in the backwards direction, the negative direction. Another thing to remember is that if my slope is going toward the x-axis, my object is slowing down. So my object is slowing down in two places: in the first part of the journey and in the last part of the journey, because they're both going toward the x-axis. Because remember, the x-axis is 0 meters per second. The object's at a standstill. If my slope of my line is moving away from the x-axis, like it is in the green portion in the second part, my object is speeding up. And if it has a horizontal line as a slope, then my object has a constant velocity. It's not standing still necessarily, it just has a constant velocity. So already, just qualitatively, I have an understanding of this object's story. This object for the first 4 seconds is moving forward but slowing down, stops instantaneously, and then speeds up, moving backward. So it's changed direction because it's now moving from the first quadrant to the fourth quadrant. Speeds up for 4 seconds, and then for another 4 seconds, it maintains a constant velocity of negative 10 meters per second squared. It's going backwards at a constant rate of 10 meters per second. And then it gradually slows down in the space of 2 seconds to a stop. My entire journey takes 14 seconds. And that's the story of what's happening to the velocity of this object: going forward, slowing down, backwards, speeding up, backwards, constant velocity, backwards, slowing down. So if I wanted to actually get quantitative measurements from this, I graph it, and the slope of my line, because it's my y-axis values over my x-axis values, will give me units of meters per second squared, which is acceleration. So in the first part of my journey, if I have the slope of my line, which would be 0 minus 15 over 4 minus 0, I get an acceleration of negative 3.75 meters per second squared. I'm going forward, slowing down. It makes sense that my acceleration is negative. Then what happens is that my object moves backwards but starts to speed up. So the slope of my line will still be negative. And as a result, my acceleration will still be negative. But in this case, the slope of my line is less severe, and so I'm going to be expecting my value to be lower. And in fact, negative 2.5 meters per second squared is a lower magnitude than negative 3.75. Remember, the magnitude is just the absolute value number. So 2.5 is less than 3.75. So it's accelerating, it's changing its rate of velocity less than here. Here I'm slowing down much more quickly than I'm speeding up here. And the reason why these values are both negative is that I'm also including direction in that. Negative slope means I will have a negative acceleration. Here I have a 0 slope, I'm not accelerating, I'm not changing my velocity, I'm not changing direction, I'm not changing the magnitude of my speed. So I have a zero slope, zero acceleration. And then finally, I have a positive slope, so I will have a positive acceleration because what I'm doing is I'm slowing down in the backwards direction. So again, if I have a downhill slope to this, my value has to be negative. And if I have an upward one, my value has to be positive. So this gives us the acceleration versus time graph from this, and I could plot those lines, a negative 3.75 value for 4 seconds for the acceleration, and then negative 2.5, and then 0, and then 5 meters per second. So I could plot these on the graph very easily. Those were just qualitative areas, not in the right place. From a velocity versus time graph, I could also find the displacement. So in this area, my displacement, my area under the curve will be positive,